Hi everyone, welcome to Lessons in Chemistry. Today we are going to cover stoichiometry and in particular, excess and limiting reactant. Let's get started. Firstly, let's try to understand the concept of excess and limiting reactants. Say, for example, you have a reaction where your reactants are A and B and they combine together to form C. Now, in this reaction, we see that A and B have a 1-to-1 molar ratio. What does that mean? That means that if you combine 1 mole of A with 1 mole of B, you will end up producing 1 mole of C. Now, this may not always be the case in a practical lab situation. You won't always have your reactants in their exact molar ratios combining together. As a result, you will have one reactant that is in excess and another reactant that is limiting. Okay? In case of more than 2 reactants, you will have only one limiting reactant and multiple excess reactants. Now, what does this mean in terms of your moles? Say, for example, you combined 3 moles of A with 2 moles of 2 moles of B in a test tube. What would you get for C? How many moles of C would be produced? Well, in A, only 2 moles will react with the 2 moles of B. The other 1 mole of A is in excess and nothing happens to it. It just sits at the bottom of the test tube. As a result, since you only have 2 moles of A reacting with 2 moles of B, you will have 2 moles of C being produced. What have we shown here? What we have shown here is, firstly, that A is in excess, B is your limiting reactant, and your final value of your product, the amount of moles, depends on the amount of moles of your limiting reactant, okay? Not of your excess reactant. So let's use this information that we have just learnt in order to try a practice problem. Our problem says to calculate the mass of silver bromide that can be formed if a solution containing 550 ml of 0.107 molar silver nitrate is allowed to react with a solution containing 10 grams of calcium bromide. Now, the first thing that you should note here is that this is a limiting or excess stoichiometry problem because you are given too much information. You are given information about both of your reactants, silver nitrate and calcium bromide. You are given the mass for your calcium bromide and you're given the volume and concentration of your silver nitrate. So what you need to do is to decipher which one is limiting and which one is in excess, and then you can find the number of moles or then the mass of the unknown, aka your product silver bromide. So, your first step when solving any stoichiometric problem is to write a balanced reaction. I have silver nitrate, AgNO3. This is in aqueous form, reacting with calcium bromide, CaBr, which is also in aqueous form, and this should be CaBr2 because calcium has a Ca2 plus ion. And this forms you want to swap partners of the two reactants. So you get AgBr. Now, AgBr is a solid because bromine is not soluble with silver. This means that this reaction is going to be a precipitation reaction. Now, a lot of the time, when you have a solid, you will state the amount as a mass. So that is why you are asked to calculate the mass of silver bromide in this case. So just a side note. The other product that you will have is calcium nitrate. So CaNO3, 2, because nitrate is a -1 ion. And this is also aqueous because nitrate is soluble with everything. Let's also balance this equation because we have 2 bromines on the left. We need 2 bromines on the right, so we put a 2 here. And now we also need 2 silvers and 2 nitrates on the left. So we put a 2 here. All right, great. Now that we have our balanced reaction, we can move on to the next step. The next step is to determine how many moles of each of your reactants do you actually have. Okay, so I'm going to label this as the amount of reactants we have. Okay, so let's first find the number of moles of silver nitrate that we have. Okay, now we are told that we have this 550 mils of 0.107 molar silver nitrate. So using our formula N equals CV, we can find our moles as 0.107 concentration times by 550.0 times 10 to the negative 3. Because remember, your volume always needs to be in liters when you are using these formulas. So the value that I get for this is 5.885 times 10 to the negative 2 moles. Great. Now what I'm going to do is to find the moles of my second reactant. I'll leave a little bit of space here. So the number of moles of calcium bromide that I have is going to be, here I'm given a mass, so my moles is mass divided by molar mass. So I will have 10.0 divided by, calcium has a molar mass of 40.1 and bromine has a molar mass of 79.9, and I have to multiply that by 2. And I will get a amount of 5.002 times 10 to the negative 2 moles. Now, a common mistake that students do at this point is to just compare the amounts of these two and say that whichever one is lower is the limiting and whichever one is higher is the excess. This is incorrect because you have to take into account the molar ratio, right? So here we have a 2-to-1 molar ratio between silver nitrate and calcium bromide, okay? So the way that you are going to resolve this and figure out the amount that is in excess or limiting is you choose either of these two, okay? Say I ignore the amount of silver nitrate that I actually have, okay? And instead, I ask myself, how much, let's write this, how much silver nitrate do I need to react with all of the calcium bromide that I have? Okay, now I have this much calcium bromide, okay? So how much silver nitrate do I need, would I actually need to react with all of that? Let's have a look. So from our molar ratios, from the balanced equation that we have, the moles of AgNO3 needed, okay, to react with all of your calcium bromide is going to be 2:1 times the moles of CaBr2 that I have, okay? The 2:1 comes from this molar ratio over here. All right, so this will be 2 times this amount, right? Which gives me 0.1004 moles. Okay, now this is where I can figure out what is limiting and what is excess. What I have to do is compare this value, okay, which is the amount of silver nitrate that I need, to this value, which is the amount of silver nitrate that I actually have. Okay, now by comparing these two, let me change the color. By comparing these two, we see that I have less AgNO3 than I need to react with all of the CaBr2 that I have. Okay, now logically this means that AgNO3 is my limiting reactant, right? And CaBr2 is in excess, okay? So why is this? This is because I cannot use up all of the CaBr2 with the amount of AgNO3 that I have, right? Because I would have needed 0.1004 moles of AgNO3 to react with all of that, okay? As a result, I've been able to tell that silver nitrate is my limiting reactant. Now what you're going to do, this is the final stretch, is use the amount of silver nitrate in order to do your subsequent calculations, okay? Because silver nitrate is now deemed as the limiting, okay? If we had said that calcium bromide was your limiting, then you would use the number of moles of calcium bromide for your further calculations, all right? Cool. Now, the question finally asked us to find the mass of silver bromide, so this one here. Then we can find first of all, the number of moles of silver bromide. This is going to be 2:2 times the number of moles of your silver nitrate, your limiting reactant that you actually have, okay? The 2 on 2 comes from this 2 and 2 molar ratio. Okay, so this is just the same amount, right? Which is 5.885 times 10 to the negative 2 moles. And finally, you can find the mass of silver bromide as your moles times molar mass, which is going to be 5.885 times 10 to the negative 2 multiplied by silver is 107.9 plus bromine, which is 79.9, and this should end up giving you a value of 11.1 grams, which is your final answer. Thank you for watching this video. If you liked it, please leave a comment, subscribe, and keep watching my next videos. Thank you.